continue doing these Verilog practice problems. As mentioned previously, I'm just going to skip this one because I don't think these K-map fundamentals are something that interviewers would ask or care to ask. Unless, of course, you're like a new graduate and they just want to know if you know any book concepts. Yeah, so it's very important when studying to be able to be flexible and skip certain concepts, because it's very easy to study and want to study every single last thing because of FOMO, basically. But it's very important to be strategic because interview studying time is limited. Generally, you book something a week or two out, and that's all the time you have to study. So like anything that isn't fundamental to your practice, you should just skip. For example, muxes and half adders. To an extent, I could see that being asked in an interview, and a lot of like these kind of basic stuff that we've done in the previous problems can be weaved into much larger problems, right? Whereas K-maps, not really, right? Like if you understand the specifications, you don't really need a sum of product or product sums or like do any kind of like annoying reduction to be able to write a correct equation. At the end of the day, it's the result that matters. Did I start the timer yet? No. Let's just open some tabs and then let's set a timer. Boom. Let's go. These don't care, which means you can do whatever. Okay, 1, 2, 3, 4. This is saying if x3 is 1 and x1 is 0, that'll cover these. So x3 is 1 and x1 is 0. Okay, so now to cover this quadrant, and then these are don't care, so I don't care. Or basically if x1 and x2 and not x3 and x4. Yeah, this is kind of close to the same, I guess. This is like x3 and not x1. Or if all the bits are 1, which is this guy. Or if we're doing 1, 0, 1, 0. So if x is so it's 1, 2, 3, 4. So 1, 2, 3, 4. No. Yeah. 3 is 1, 4 is 0. So we've got this, we've got this, we got this. So we need like these two, which is going to be if x2 is 0 and if 3 and 4 are 0. If they're both 0, this would be a 1. And if any of these are 1s, this would be a 0. Let's see if the previous one's good. I see. So in N, oh, I see. I'm just implementing left-hand side. So mux 0 will be this. Which is just basically if it's not if basically if any of those are 1, mux in 1 is just gonna be 0. Mux in 2 is gonna be if CD is 1, 1. So basically that. And then assign mux in 3 is gonna be if D is 0. So if CT is 0, mux in is 4. So 0, 0, 1. Oh, these two are swapped. I see. I see. These two are swapped. So it's 0, 0, 1, and then 1, 1, 1, 0. So just swap these. Just, okay. Tricky dick. Create 8 flops. And then it's still the same. There's no reset here, so it's kind of like awkward. With active active high synchronous reset. Try to pause a clock. So if reset neg edge clock or because active high reset will just pause edge it. So if reset pause edge clock or pause edge reset. Pause edge clock, pause edge reset. So I guess they just want it to take effect at the next pause edge clock. So then here, I guess they also don't care about the edges of the clocks. So this isn't very synchronous reset because I would have thought synchronous was synchronous with respect to clock, right? But this reset can come at any, well, okay, fair enough. This feels asynchronous to me because you're not really, or maybe the thing I was doing was asynchronous because the neg edge pause edge reset can come at any time. So I'm triggering this without the respect of a clock, but here I have to do with respect to a clock. Okay, so this is done, and this is done and quite educational. So I guess synchronous and asynchronous I had mixed in my mind. Synchronous means there's no condition in the always, and then synchronous means this is always attached to this clock. I guess the trade-off is if you have like pause edge clock and negative reset n or pause reset n, it's asynchronous, but if reset is part of the same clock domain, then you kind of avoid a bit of race conditions, like between clock and reset. But I guess that's not a big deal. So let's test that theory. Very curious how this one turns out. active low reset. Asynchronous active low. So this is kind of more the canonical thing where you do then you would do what's the rest of the spec? There's a few ways to do it. The easiest one is probably just do byte enable 1. Oh, it's a synchronous. Okay. Cool. Asynchronous resets. So if reset else begin Q is D. Okay, no reset. So in XOR with this out net, and then also that was pretty cool. Consider this below, write your solution here. Assume that you want to implement hierarchical Verilog. Use 3 instantiation of a submodule that has a flop and a mux in it. I see. Oh, I see. So it's just talking about this. What is Q in? Okay. Output rec Q. All right. So is gonna be if it's R in, if L, then I want to choose R in, and if not L, so 0, then I want to choose Q in is my mux out, which is this wiring, and then assign always at positive clock, no reset here, again kind of weird. Then my Q is just going to be this mux out. Okay. E and L are your selects. So probably like that. Mux 1 out being this guy, mux 2 out being this guy. Mux 1 out is going to be selected by E. So E and what? E and W, or not E and Q. So L is 0, chooses mux 1 out, otherwise it chooses R. Okay. And then this always positive clock. Gonna just be this mux 2 out. Given FSM, assume, given the FSM circuit, initiate set to be to build the circuit. The D, okay. So okay. Post X just refers to these 3 nets. So maybe just top to bottom is gonna be x XORed with how do I want to build this? I probably want to just have logic of Q and not Q. So this will just be XOR of Q0. And then this will be X and not Q1. And then this will be X or not Q2. So then this would be post X0, post X1, this wire. And then this will be post X2. And then what will then happen is this post X is on my D pins. So then my Q and Q is just gonna be post X and not post X, basically. And then my Z is just going to be this NOR of Q. Right? Yeah. Probably I will stage for the run for this one just because it's a little bit complicated. So X is 0, expected. Assume that the D are initially set to 0. Oh. Zero should yield 0. I'm wondering how to reset this without a reset. So assuming this was 0, then this is 0. And this is 0. And this is 0. So if all 0 is 1. So assuming this is 0, then zero XOR 0 is 0. So this Q, which is this post X flopped, is 0. And X, so this is 0 and 0, so this is XOR 0 and a 0 or a 0, so they're all zeros. Oh, actually no, because post X here is not post X, so yeah, without a reset signal, this is a bit hard. So I guess I can't do this. And I must explicitly do that. At reset, Q assumed to be 0, but then NQ is also 0 in my previous implementation. So this forces the issue of the NQ just being like not like an inverter of this, as opposed to a more convenient way. But then the convenient way depends on this D pin, and the initial conditions will be wrong, because you need at least, in the previous implementation, you need at least one cycle for the Q to be set. So timer, how we're doing, 2/3, all right, cool. Okay. Well, something we know is if we have to do this in D flip-flops, it's always going to be underneath a clock domain. And then so if if J is K, then we want Q to be basically where's the reset? It's so odd without reset. Q if J is 0, because that means it's 0, 0, or we have not Q if J is positive, because then if J is positive and they're equal, that means JK is 1. Else begin, we can else here because this would be XNOR, and then this would be XNOR. And then so Q here is just simply going to be if J is 0, it's 0, 1 is 1. For clarity in one, so basically implement this waveform. Detect when the input signal change is 0 in one cycle to one to the next. So this only happens, this always happens one cycle after. Let's check this. Okay. This always only happens a cycle after. Q meaning my in edge is just basically going to be if so this cycle is currently a 1. Maybe I can name this prev for better labeling. So 0 in previous cycle, 1 in this cycle, then an edge is detected. And so 1 cycle later, meaning if any in edge is detected, so any pause edge of in is detected, then next cycle is going to go ahead and take this in edge. So this handles pause edge in this cycle, and it also serves as a gator to say if any is detected in this cycle, go ahead and flop it in the next cycle. Is any edge, so same as previous problem, but this is somehow okay, yeah, I can't clock gate it. I can only just delay it by cycle, otherwise it'll become sticky. Let's see if this works. Okay, I won't copy paste because I just maybe want more practice on this one. So any edge is gonna go from like if there's any difference detected. Okay. Let's see, no mismatches, cool. So I'm detecting 1 to 0 transitions and then setting this output to 1 cycle after. Synchronous reset, if both at the same time reset has precedence in the last 4 cycles of the waveform, reset occurs 1 cycle earlier. 1 to 0 transition. So 1 to 0 transition happens here. So I set it 1 cycle later. Yeah, I guess these problems are starting to get hard because there's a lot of things to remember about the spec. but it is a synchronous reset. So if reset no matter what, next cycle, we need the output to be 0. Should we reset to 0? Okay. Now, if I'm not at a reset situation, then so here, I'm not at a reset situation. Then there's going to be some this is the previous issue where like we need it to be sticky. Low detect is when we go from 1 to 0, so this will have a current cycle snapshot when we go to 1 to 0. This says, hey, did we detect anything? If we did, go ahead and accumulate whatever snapshot in this cycle and then sticky it into the out, but then the out is reset to 0 when reset happens. And then in this particular case, let's say a rear reset, this next cycle is 0. That's great. But then the next cycle, we actually hit this case statement, and then we will have a load detect for bit number 1. So this will evaluate to true. Bit 1 would be true as in is 0, and then this in prev was 1, and then we just OR it 1 0 with all zeros, resulting in 1 0 in the next cycle. However, don't have, and that is not accepted as a legal sensitivity list. Why not, actually? They don't really explain this. I'm curious to know, like, okay, this is success. So basically, that you want to update your queue on any pause or neg edge of the clock. Without using pause edge or neg edge clock. So, Okay, well, I see. So I guess FPGA synthesis isn't smart enough to, like, if you do this, it doesn't just say, let me just make two flops. I see. So then you have to split it out. Okay. Because this one I wasn't like thinking like, I guess I read this as like, just an FPGA only has flops of one sensitivity or the other. But I guess this really means there's no FPGAs with a flop that has both. And also this implies that this won't ever be synthesized to two separate flops, which makes sense because flops are individual units. So, yeah. Okay, so if I'm a pause edge of a clock, then so suppose I pause edge clock and my D updates. Then so at pause edge, it'll always get wherever D was, and then at like neg edge, it'll also get whatever D was. So isn't Q just so in this case, Q neg would be positive, but Q, I don't want to say I can just OR them. You know what I'm saying? Like, because if this deasserts in the middle and 1/2 needs to deassert, so one of these two always have the most updated information. Like if I go to 0 here, then Q pause would still be 1, but Q neg would be 0. Interesting. Can I just do this? No, I can have multiple drivers, even if they happen at strictly different times. I got it, okay. If Q pause is 1, oh, I see. So this is delayed by a cycle, and then I can say updated. So as soon as there's a change in any of these, then and I know these can't happen at the same time, so if Q pause updated, I take this, and if Q neg updated, then I take Q neg. This is actually quite a good problem, but I have 60 mismatches, so maybe not. So here, neg edge. I see. Q neg is 0. This just goes to 0. Is there a way to so Q neg is saying like, so I know Q pause is 1. Here, and then it goes to 0 here in this neg edge. So Q neg is 0. Wonder if I can do like if I XOR these two, I'll know some update has happened, but I need to know which update has happened. So if Q, Q pos is 1 here, and then Q neg is 0 here. How do I know what? If I have a pos edge update, I need to update it on the neg edge. Okay. So like, this will tell me I've updated something. So like, go here, and then this will be 1. But oh, suppose Q has updated and I detect it. Then at the next edge, I need to update Q. So for example, if this is 0, I'll need to get Q pause Q neg. And then I don't even need this. So then these two would just have, either of these are up to date. When I have a pause edge, I know Q pause is the most up to date. So when clock is deasserted, I will just take the pause edge. Likewise, the converse is if the clock is up, then I know the most updated thing. So pause edge is this, and then if it's neg edge or clock going back to 0, I would take this edge. Now, if neg edge, this Q neg would be updated, and then when the clock is asserted again, it'll have to look back into what happened in the neg edge, and then update that. Okay, still wrong. What if I swap these? Because I get this is a bit late, so for example, if one asserts here, I guess pause edge clock will just clock this a cycle later or something. But if I take the neg edge and then I clock this, then I'm not sure actually. Okay. So yeah, there is that delay which I guess screws up the problem. So if neg edge clock here, I'll go ahead and grab this thing that occurred on the pause edge and then go give it to Q pause, and then this Q pause would be qualified with negative clock. So then it will go here. If it goes to 0, I'll latch it on the pause edge, and then on the pause edge when clock is 1, I'll pass it through. I guess better naming is, reversing these names, but it doesn't matter. Yeah, this was interesting to think about. To use level sensitivity of a clock, which I haven't played much around with, in conjunction with using the opposite bias of the clock to grab the information that occurred on the other edge of the clock. Yeah. Anyway, that's it for this one.